right, last triangle problem here, and this one's a little bit of a monster because we're dealing with tangents. So we have secant is 2 and secant is 3. So these are a little bit messy. We need to do our triangles first. I, again, never like dealing with secant and cosecant and cotangent. You guys know that. I would much rather deal with sine and cosine. So if secant is 2 over 1, then I know cosine is 1/2. And here are details about where this is living. 0 and negative pi over 2 is going to be quadrant 4. So cosine is 1/2. Cosine is adjacent over hypotenuse. Sorry, not little h. So here's our adjacent, here's our hypotenuse. Hey, does that look familiar? It should. You can absolutely do the Pythagorean theorem here, and if that is what keeps you comfortable with these problems, that's fine. But if cosine is 1/2, then sine is radical 3 over 2. This is a unit circle angle. It doesn't look like it the way I've drawn it. It's definitely, well, it might be almost drawn to scale because it would be a pi over 3 angle. But pause and do the Pythagorean theorem if you need to get that value. We are dealing with tangents here, so what we need is tangent of A. And tangent of A is going to be opposite over adjacent, which is just negative radical 3 over 1, which is just negative radical 3. So there's our tangent of A. All right, let's do our B triangle before we move forward here. Secant of B is 3, so that means cosine is 1/3. And here we're 3 pi over 2 to 2 pi, again the fourth quadrant. Cosine is adjacent over hypotenuse. And this is also a triangle that we've done even on this review. Again, the Pythagorean theorem is what you would use here in order to find your value. It's square root of 8 or 2 radical 2. You can absolutely take a pause and do that math if you need to. It's also done on my key. Tangent then of B, and that should be a negative because it's a down, is opposite over adjacent. So negative 2 radical 2 over 1, which is negative 2 radical 2. All right, we're going to do tangent difference identity and then tangent of 2b. So our tangent difference identity is going to look like this. Tan of A minus tan of B over 1 plus, and again, those signs, sorry to stop in the middle there, those signs are following from this guy. If there's a minus in between, we have a minus on top and a plus on the bottom. If there was a plus in between, if we were doing tangent sum, those would be flipped. There would be a plus on top and a minus on the bottom. Okay, 1 plus tan of A times tan of B. And then we're going to plug in those values. Tangent of A is negative radical 3. Tangent of B is negative 2 radical 2. 1 plus tangent of A times tangent of B. Don't be freaked out about the radicals. You know how to rationalize the denominator. From here on out, this is algebra 2. You have to be careful. Algebra 2, careful. On top, we're going to do this negative, negative, and make it a positive. So we have negative radical 3. Negative times a negative is positive. 2 radical 2. And on the bottom, we have 1 plus, I have negative times a negative here, so that's positive as well. I have a 2 here. It doesn't have it, there's nothing else on the outside there, so it's just going to be a 2. And my radicals can multiply. So radical 3 times radical 2 is radical 6. This is your unrationalized fraction. Now we're going to rationalize. And the way we rationalize, and this could have very well been a problem on your entrance exam, it's very similar. We're going to multiply by the conjugates. The conjugate is the binomial, the two terms that we have on the bottom, and we're going to switch the sign in the middle. What this does, the reason you have to switch the sign in the middle is that you're making a difference of squares. So the middle terms that would still have radicals cancel. And so when you do that, radical 6 times radical 6, it's going to undo that square root. What we do to the bottom of our fraction, we have to do to the top. And now you FOIL your brains out here. Okay. Just carefully. Negative radical 3 times 1 is negative radical 3. And when I'm FOILing here, I look through it kind of 2 times. I do negative times a negative is a positive. I have nothing outside my radical 3 and a 2 out here, so it's going to give me a 2 on the outside. I have 3 times 6 under my radical. 3 times 6 is 18. I'll work on breaking down that radical later. Now, 2 radical 2 times 1 is 2 radical 2. And 2 radical 2, okay. So a positive times a negative is a negative. 2 times 2 is 4. Square root of 2 times square root of 6 is square root of 12. Again, do it in the little pieces. Look at those little pieces carefully. Okay. We'll come back and condense those radicals where we can, but let's keep FOILing. On the bottom, 1 times 1 is 1. 1 times negative 2 radical 6 is negative 2 radical 6. 2 radical 6 times positive 1 is positive 2 radical 6. 2 radical 6 times negative 2 radical 6. Be careful with your positives and negatives here. Positive times a negative is negative. 2 times 2 is 4. Square root of 6 times square root of 6 is 6. Have to be really careful. Really careful here. Just taking a pause so you can look through those. Look through those numbers if you need to. Okay, we're going to keep going. In the denominator, some nice things happen that we designed by using the conjugate. The middle terms cancel. This is negative 24. So my denominator is just 1 minus 24, which is negative 23. I still have some work to do in my numerator to simplify. I have this square root of 18. 18 is 9 times 2, and 9 is a perfect square. Square root of 9 is 3. So what this turns into is 2 times 3 times square root of 2. So I'm going to bring some stuff down here before we go any further. I have this negative radical 3 that I can't do anything with right now. Plus. We just worked on this. 2 times 3 times radical 2 is 6 radical 2's. The 2 radical 2 here in the middle, there's nothing to do with it yet. But we can break down this 4 radical 12 and work with it. So I have 12 is 4 times 3. 4 is the biggest square root that goes in. Square root of 4 is 2. I have this 4 out front, and it's negative. So that's going to be negative 8 radical 3. There is a lot of detail work here, but none of the detail work is hard. None of it's above your ability level. It's just a lot of detail work. Okay, now we're going to combine our like terms. Negative radical 3 minus 8 radical 3 is negative 9 radical 3's. 6 radical 2's and 2 radical 2's. These work like variables. It's 8 radical 2's. And we have negative 23 on the bottom. You You can bring that negative up by switching all the signs. You can leave it like this. Whatever works for you is okay with me sign-wise. If you were going to bring that up, we'd do positive, positive, negative there. And that's what my answer key looks like. Luckily, tangent of 2b works out really nicely. Okay, take a breath. We're almost done. Tangent of 2b. Our double angle tangent formula looks like this. 2 tan of our angle over 1 minus tan squared of our angle. Even though we have a square root going on here, our tangent of b is negative radical 2 over 2. It's actually going to work out nicely because we're going to square it in the bottom. So I'm going to plug in tangent of b is negative 2 radical 2 Again, just like with the last problem, this one is much shorter, but there's a lot of detail work to do. So work carefully. We're multiplying 2 times negative 2 to get negative 4, and the radical 2 stays with it. On the bottom, we have 1 minus. Square the negative, it becomes positive. Square the 2, it becomes 4. Square the square root of 2, and that becomes 2. And you have no radicals here, which is lovely. Especially after all that radical work we did on the last problem. That's 8. 1 minus 8 is negative 7. Negative divided by a negative is positive. If you struggle with those tangent problems, go back and find some that you can work on within this unit's practice. There were several practice problems that you could work on here. See me if I can help.